So now we want to wire up the actual command handling to add or save an edited customer as well as canceling. So we're going to need to add a couple buttons to this form. To do that, I'll drop into the XAML, and we're going to expand the containing grid here to have 2 rows to it. The first row is where our data entry fields are going to go. The second row is where our command buttons will go. So let's drop to the bottom here and add that second row, which is going to be another grid containing 3 buttons. A save button, an add button, and a cancel button. Obviously, if we have this add edit mode to this thing, only one of these buttons really applies at any one time. So we need to hide or show one of these buttons. Now, one thing that may immediately occur to you is, gee, why don't we just have one button and dynamically populate what the button says from the view model based on our edit mode? And while that may seem like a perfectly viable thing to do, it brings up an important concept about MVVM and the appropriate roles. If you remember from Module 1, I said it's the view's job to dictate what the user sees on the screen. And the view model just provides the interaction logic and the data manipulation to support that. If your view model is trying to push text to drive the content of a button, that may sort of violate those principles. What if you later bring a designer into the mix and he decides to rework that XAML and use icons instead of text? Should you then be pushing icons to the view from the view model? No, that's pure presentation. That's really the view's job. So to protect against that, we go ahead and put the 2 buttons in there, and we will drive their visibility from a property exposed on our view model. So then you may say to yourself, great, I'll just expose a property of type visibility from my view model, and I'll set the visibility with a binding like this. But once again, if you really look at it from a separation of concerns perspective, visibility is a pure presentation aspect. That is a responsibility of the view. So you really shouldn't be exposing visibility properties from your view model either. So what's a poor MVVM coder to do? Well, you can easily expose flags or booleans from your view model that are decoupled from how that flag drives the presentation. So we still want to bind the visibility property here, but we want it to be driven by a boolean flag. Now there is a built-in boolean to visibility converter we could use. Unfortunately, that one doesn't let you negate what your flag means, and it also is hard-coded to always use collapsed as the false state. As a result, in any of my projects, I usually have a custom converter to deal with these kind of situations. So let's go add that to the project. So over here in my project, I added a converter subfolder and a class called negatable boolean to visibility converter. Kind of a big mouthful, but it's very descriptive of what this converter can do. The implementation you can see on your screen. It's a class that inherits from my value converter. It exposes 2 additional properties that can be set when you create an instance of this from your XAML resource dictionary. One to say whether to negate the meaning of the Boolean flag, and one to drive what the false visibility is. And usually you'll be setting that to either collapsed or hidden. So we default to collapsed here. And then just a chunk of logic, probably more elegant ways to write this, but basically combine those 2 flags. The Boolean flag that comes in from the binding, and the negate flag, to say whether we should be visible or whatever the visibility of our false visibility property is. Now to use this in our view, we need to go up to the top and add another XAML namespace for the converter's child namespace. Then we're going to want to define 2 instances of our visibility converter, one where we set negate to true and one where we don't. And then finally, we can drop back down to where our buttons are and set the visibility using our existing edit mode flag on our view model and using the appropriate instance of our visibility converter. This one, if we're in edit mode, we want the visibility to be visible because it's the save button. And the add button, we want to negate the meaning of that edit mode to hide the add button when we're in edit mode. Now let's go hook up command handling for our save command and our cancel command. Switching over to the view model. Standard pattern here that you've seen many times over now. We declare our commands as properties we can bind to. We construct our commands in the constructor of our view model, pointing to the handling methods. And in the case of save command, we're going to end up driving this with validation, so we have a can save or a can execute handler. And then at the bottom of the class, we can stub out those handling methods for now. Now, much like we did in the customer list view, we need to be able to signal our parent view model when we're done with the editing or adding process, or when we cancel. So we'll add an event called done that we can raise from this view model, and the parent can handle that to drive navigation. We'll drop back down to those handling methods, and for now just call done in each one of the handlers. Then we go up to the parent view model and add an event handler for that done event. And finally, add that handler method, which sets the current view model back to whatever we want when we're done with the editing, which in this case will be to go back to the customer list view. With all that in place, we can fire this up, go to Customers, edit a customer, make a change, save it, and naturally we don't see that it was saved because we haven't wired up any save handling yet. We'll get to that in a subsequent demo. We could add a customer and decide to cancel, and we end up back where we wanted. But before we try to save the added or edited customer, we need to validate that data first. So let's talk about validation.